thing will be equal to 0. Okay. So V is equal to, so 2 times 2, 4. 4 times, so 20V over 56 minus by 30V over 28. So this will be 20 over 56 minus by 30 over 28 is equal to minus 5 over 7 B, right? VA. Sorry, so I got an A missing down here, VA. Okay. So E is equal to minus 5 over 7, right? So you and you have to multiply by A. And when you see the minus down there, okay, it means that minus means it's going to the left hand side, yes or no, right? Minus is left, positive is right. So the shear center is left from point C. Okay, if it's plus, means it will be on the right hand side. So it's quite straightforward, isn't it? Is the procedure, right? It's so straightforward to understand why we are doing something a certain way. Okay, it's not that difficult. I'm going to do another example. Okay, another example which is I hope it will clarify some things for you all if you all get a bit confused on. Yeah. So I want to do another example so you can do your homework. Okay. So the next example I'm going to do is example number 2. Okay, so it's this example over here. Okay. Right. So we are given that we have an extruded beam. Okay, with cross section is shown. Determine the location of the shear center. The distribution of the shearing stress caused. So now we have to find the distribution of the shearing stress. Okay, so everything is still the same. Okay, I mean same like the previous example, but now we have to find the shearing stress. Okay, so the thing that is not the most difficult but confusing is how the F1 and F2 will move. So that is dependent on the Q. Okay, so from here we apply rule number 5. Right, remember rule number 5 that the shear flow, right, this is controlled by the web. Right, we know this. Right, so this is our Q, our shear flow. When that's the case, then the Q will go this way. And so with this, right, now we can see that I'm going to call this F1. Right, so this is now this is your F1 in this direction. Right, that's your F1. And then this direction over here, this is F2. Right, and later on we're going to take moment at point C again. Right, and we'll take moment at point C. So First thing of all, second moment of failure again. So we know we have to determine shear stress. Right, the question asks for shear stress. So to find the shear stress, we have to apply BQ over IT, right? But first of all, we have to determine the what? The shear center first. Okay. First of all, we have to determine the shear center. If we don't determine the shear center, we cannot apply the work formula where BQ is equal to IT. Okay. Okay. So we have to find the shear center first. Okay. So we are going to look for IZZ. So this is our transformation that we're always going to use. Y, and this is Z. Okay. So IZZ is equal to the IZZ of the web plus by twice of IZZ. Okay, twice of IZZ of our flange. Okay. So IZZ of the web. So our width is T. Our depth is 6 plus 12 plus 12, 10 cube over 12 plus by twice, right? So the width is equal to 4 T cube over 12 plus by 4 multiplied by T multiplied by 6 divided by 2 squared. Okay. And we can drop this term to be equal to 0 because of T cube is very small. It's 1/8, right? It's so small, right? So we can drop it. So finally, if that's the case, this will be equal to 10 power 3 divided by 12. It's 250 over 3t plus by 3 squared times 4 times 2, 72t. So this will be equal to 250 plus by 72 is equal to 322. Wait, no. 250 over 3 plus by 72. No, 250 over 3 plus by 72 is equal to 466 over 3t. And then this is 466 over 3 multiplied by 1/8. So this is equal to 466 about 3 times by 1 over 8 is equal to 233 over 12. Okay. So this is inches to power 4. So we found our I. So like what we have before, we know that F1. Okay, we know that F1. Right, we know that F1 is equal to F2. Okay, we know that F1. Right. Whatever is at C running along C, okay, we don't need to calculate any of the forces. This is because there's no perpendicular distance, right? So you can, so we just need to concentrate in section BD now. Okay, so F1 equal F2, and we just look at section BD. Okay, so section BD. So this is B, and this is D. This is my Z, and this is our centroid. So from the diagram, the distance is 3. Okay, so here to here is 3. Right? So this is so much easier than the previous example. So QBD is equal to width multiplied by depth. The width is Z, the depth is T, the Y bar is equal to 3. Okay, so this is 3TZ. Right? So again, just substitute shear stress BD as a function of Z. So this is equal to V over IT, and then you multiply by 3TZ. Right? Oi. Yep. Okay, 3T. Sorry, my computer is doing weird stuff. It gone blank. And now I think I can't write somehow. Something has gone wrong. Microsoft. Hold on, let me see if I can do anything. Yeah, I think I crashed. Let me get back in. I'm still around, okay, so don't worry. Let me get back in. See, can I write? Oh, hallelujah. I can write. Okay. All right. So I know what is our I value, right? So this is equal to V over I. I can cancel the T, right? So the I is 233 over 12. So 12 over 233 basically. So 12V over 233. Then multiply by 3Z. Okay. So this is 36 BZ over 233. So now we can find our forces, right? So F1 is equal to F4. We're going to integrate 0, and the distance between BD is 4 inches. 4. Okay. Shear BD Z, and then we have the thickness T dz. Okay. So this will be equal to 36V. I'm going to put the constant outside over 233. Right. So this will be 0 to 4. Right. Then we just need Z. Right. We just need Z dx. Okay, Z. I'm going to put T outside. Okay. Then dz. Right. So this is equal to Z squared divided by 2. So 36 over 233. V multiplied by 1 over 8. Right. And then is Z squared divided by 2. And then limit 0 to 4. Okay. So this will be equal to 4 times 4 divided by 2 times by 1 over 8 times by 36 over 233. So it's good. 36. Hey, I'm not getting the right number. 16 divided by 2. Wait, 16 divided by 2 times 8 times 36 divided by 233. Wait, there's something wrong. I think I'm doing something wrong. So Z squared. Oh no. Yeah, I think I'm correct. Maybe I don't divide by the T because the T later can be cancelled. Okay, so 4 squared divided by 2 times by 36 divided by 233. So equal 288 over 233. So VT okay. So now once we have this, right? we're going to take moment at point C again, right? So we're going to take moment. So let me copy